Let's look at question 5. Again, is a delta connection. Synchronous motor has this reactance, no resistor, loss, and the motor is supplying 15 horsepower load to the shelf. Okay, so that's the P output with the initial power factor lagging, and field current is certain amount. Then we did this several times. We want to calculate the IA and EA to solve this circuit, and we know that the voltage, terminal voltage, is the phase voltage. Okay, we know that that's the phase voltage. It's VT, V phase, they are the same, but the other way around. So the current goes in. This is a line current, and that is the phase current are different. Okay, and we know that a P in here equals to root 3 VL IL power factor. And what we got here is P in divided by 3. It's not root 3 here. So what is that? So in this case, it's actually also equal to 3 V phase I phase power factor. Okay, so the corresponding V and I give you the apparent power here. Okay, and you multiply 3 phase. That's the total apparent power, and power factor, you got the real power here. So this is the same. This is not. So what you actually calculate here is not IL, is IA. Okay, IA is the phase current. So the calculation is all good. You can see that here. It's just a typo here. Okay, and then after that is everything is all good. Okay, EA is equals to the higher voltage minus the voltage drop. Then you calculate this EA, so this is always 0 degree, and then you got EA. Okay, and the second question start from here. The motor flux increased by 25%. What does that mean is if I say the field current increased by 25%, that's a totally different thing, because if you remember that is nonlinear relationship. I don't know how much the EA gonna change, but if the flux increased by 25%, I can quite confidently say the new internal voltage is 1.25 times larger than the previous one. So we got the new EA. Okay, and the P here is the EA1 VT over XS. That's the power for the first section, the original one, is equals to the new internal voltage, same terminal voltage, XS. I forgot sine delta number 1 here, and this one times the sine delta number 2. Okay, so we know this one is negative 17.5 degree. We do not know this. That's what we want to know. We know EA, we know EA1, we know EA2. We all know them, and these are cancelled. So we can find the relationship, got this delta to have a new value. And then we use the Ohm's law, the high voltage minus the low voltage in phasor form divided by J-axis, you got the current. Okay, and the current phase difference with VT. Okay, VT always got 0 degree, then that is the power factor angle, and cosine of that angle is a power factor, your power factor. Okay, the current is in front, is a positive of the voltage, so it's a leading. Okay, so the last part is if we assume that we said this flux is not current usually related to linear related to the field current, but in this question we'll assume they are linear. So you can use this equation to calculate the corresponding field current. All right, so that's it.